Good morning, everyone. Welcome you to Arkajan Online. My name is Akash Kumar Bhagat. I have completed my BTech in Electronics and Communication Engineering from Bengal College of Engineering and Technology, Durgapur. Thereafter, I have completed my Masters MTech in Digital Electronics from Visvesvaraya Technological University, Belgavi, Karnataka. I am having an experience of 12 years in teaching. Presently, I am working in Arkajan University as an assistant professor. Here I handle the subjects like artificial neural network, R programming, uh, machine learning, artificial intelligence, and IoT with mini project. I have published several national and international journal papers in reputed journals. Now, today we'll start with a new module, logic gate and Boolean algebra. So this is our PPT on logic gate and Boolean algebra. So this is the first slide. Next, this is logic gate and Boolean algebra. Learning objective. So what is the learning objective of this course? So at the end of this course, the students will be able to understand the historical development of digital computers from early mechanical calculators to the modern electronic devices. They will also identify the different types of computers, including personal computers, server, and specialized systems like supercomputers. At the end of the course, the student will also have the concept of supercomputer. Next, they will explore the diverse applications of the computers in different fields such as business, healthcare, entertainment. And students have to also examine the profound societal impact of computers on communication, education, and employment. They will analyze the emerging trends in computing technologies and ethical considerations related to privacy, security, and artificial intelligence. Next, introduction to logic gates. So in this presentation, we will discuss about the basics of logic gates and various gate functions. So introduction to this digital logic. In digital circuit, we have to process the binary numbers. So we have the binary data as zeros and ones. For the logical operations, these logical operations are performed using these logic gates. What are the various types of logic gate? We have AND, OR, NOT, NOR, NAND, XOR, XNOR, and many more. These logic gates will be used to develop combinational logic circuits, and it is also used to develop sequential logic circuit. Various types of registers they can develop with the help of these logic gates. It is used in computers, microcontroller, and the embedded system. Now, computer, we all are aware of what is a computer. Okay, in this course, in the first module, we have discussed what is a computer. A microcontroller. What do you mean by a microcontroller? We can define the microcontroller when we consider the central processing unit in a single chip. So, it is having both arithmetic logic unit and also the control unit on a single chip. It has having the controlling operations is known as microcontroller. Now, how it is different from the general processors? In this course, we are talking about the central processing unit. So that is our microprocessor. And how these microcontrollers are different from the microprocessors. These microcontrollers are designed to perform a dedicated task, whereas processors they have designed to perform general tasks. They are known as general computing devices, whereas these microcontroller they are considered for a dedicated task. That's why it is used for a special type of system. So if someone want to design a particular system that is not computer, but it will work one or two tasks as it will be done by the computer system. So these systems are known as embedded system. So these are the electromechanical device that is designed to perform a specific task. And instead of using microprocessor, these embedded systems, they are using, instead of using microprocessor, these embedded systems are using microcontroller. Next, why logic gate? We have to use this logic gate to perform basic arithmetic and logical operations. So we need to take some decision, and these decisions are taken by these logic gates. The circuit which you have to design to implement to take this decision will be implemented with the help of these logic gates. We can say these logic gates are the functional component in designing a circuit. Now these logic gates, they are used in the computers, artificial intelligence, networking and automation. Now briefly we can say these logic gates are very much essential for the circuit design and to perform Boolean algebra. Next, what are the various logic gates? An overview, we have the various logic gates: AND gate, OR gate, NOT gate. For derived gates, we have two categories: fundamental gates and the derived gates. Derived gates are those gates that can be derived or that can be built using these fundamental logic gates, that is our AND gate, OR gate and NOT gate. So derived gates are our NAND gate, NOR gate, XOR gate, XNOR gate. Next, so AND, OR and NOT gates. AND gate is output is 1 only if both the inputs are 1. Output will be high if both the inputs are high. OR gate, output is 1 or high if at least one of the input is high. NOT gate, it is acting as an inverter. It simply take the input and convert it in the reverse, just complement of the input. That is, if you take 1 as an input, it will be converted to 0, and if you take 0 as an input, it will be converted to 1. This is your NOT gate. Let's start with the discussion of these gates with the help of truth table. So truth table, we have the truth table, say A as an input, B is also as an input. So what are the possible combinations of this two input AND gate? So for two input AND gate, maximal number of possible combination is 2 to the power 2, that is 4. So input combination 0 0 0 1 1 0 1 1. So what will be the output for this 0 0? It will be 0 for AND gate. For 0 1 it will be again 0. For 1 0 it will be again 0. For 1 1 it is 1. So that's why it is written in the previous slide, the output is high if both the inputs are high in case of AND gate. OR gate. OR gate, the output combination A or B. So the inputs that will be given is A and B. So the two input maximal number of possible output is 2 to the power 2, that is 4. The combination, possible combinations are 0 0 0 1 1 0 1 1. So A or B, 0 0 0 0 1 1 1 0 1 1 1 also 1. So for any given input, high input, for any given input, your high input, your output will be high 1. So for given input 0 0, output will be 0. For 0 1, output will be 1. For 1 0, output will be 1. For 1 1, it is also 1. Next, NOT gate. For NOT gate, we have the complement of the input. Say for 0, output is 1. For 1, output is 0. Universal gate. So in case of universal gate, we have NAND or NOR. NAND and NOR can be implemented in any logic circuit. In any logic circuit, we can implement NAND and NOR, and these any gate, any fundamental gate or any circuit can be implemented using this NAND and NOR gate. So these are known as the universal gate. All other gates can be realized using this NAND and NOR gates. So the realization of other gates using NAND gate and the realization of all other gates using NOR gate. So that's why these two NAND and NOR gates are known as universal gate. It is very cost efficient for the circuit designing. Next, truth table for the NOR gate. So it is reverse of OR gate. Whatever output we observe in case of OR gate, that will be getting reversed. The complemented output we will get for the NOR gate. So the inputs are A and B. So the input A and B are the two input we are supplying to the NOR gate. We are observing the all possible combination that can be implemented using two input. So the maximum number of possible combination is 4 because 2 to the power n, here n is the number of inputs. So we have two number of inputs. So 2 to the power 2 equal to 4. So 4 possible combination, that is 0 0 0 1 1 0 1 1. So A nor B, it is 0 0, output will be high 1. For 0 1, output will be low 0. For 1 0, output will be low 0. So for 1 1, both the inputs are high, the output will be low 0. Next, NAND gate. So NAND gate, one NOT gate is added at the output of the AND gate. So we will simply get a complemented output in case of NAND gate. So whatever output we get in AND gate, the reverse we get in case of NAND gate. So the possible combinations are 4. So the total number of input is 2. So 2 inputs, first is A, second is B. So the inputs for 2 to the power 2. So possible number of output is 2 to the power 2, 4. So 0 0 0 1 1 0 1 1. For 0 0 output is 1 high, and for 0 1 output is 1. For 1 0 output is 1. For 1 1 output is 0. XOR gate. XOR gate, we have input combinations A and B. For different combinations of A and B, again we have 4. Maximum number of combinations for 2 input XOR gate is 4. 2 to the power 2, it is 4. So 0 0 output will be 0. For 0 1 output is high, that is 1. For 1 0 output is high, that is 1. So we have output in case of these two combination, that is our A bar B and A B bar. So the expression for XOR gate will be A bar B plus A B bar. And the final one combination, that is both the inputs are high, A is high and B is also high. So output will be 0. XNOR gate. We have XNOR gate, the combinations for a 2 input XNOR gate, maximum number of possible output combinations are 4. 0 0 0 1 1 0 1 1. So the outputs are for 0 0 it is 1. For 0 1 it is 0. For 1 0 it is 0. For 1 1 it is 1. Now applications of logic gate. So these applications, these logic gates, they are applicable in various devices like processor, calculator, data storage, networking. So if suppose anybody wants to design a calculator, so this is what your logic gates will be very much applicable in designing a calculator. For processor, they are very much applicable to design the processor. Which processor is a device which is the heart of your computer system, which takes the input and process it and delivers the data as an output. So this is known as the brain of the computer system. But data storage means memory devices. Storage we use logic gate. So implementing an adder using logic gate. So an adder will be implemented using the logic gate. Next, gate delay and performance. Logic gates have a delay in processing signals. So they have to process the signals with some delay, and if you want to improve this delay, we have to enhance the quality of our logic gates. So these faster gates, they improve the system performance and the efficiency of the system. Next, summary. So for logic gates, from the foundation for digital systems, so we had studied the what do you mean by the logic gates, what are the different types of logic gates, fundamental logic gates, derived logic gates. Fundamental logic gates we have studied AND gate, OR gate, NOT gate. Derived logic gates we have studied X or NOR gate, NAND gate, XOR gate, XNOR gate. Now, basic and universal gates are essential in circuit. Now, Boolean algebra and its application. So, truth table, we will study the truth table, K-map simplification and real world use cases. So, start with the truth table. So, what is Boolean algebra? See, this Boolean algebra, this is a mathematical approach to the digital circuits. In logic circuits, where you have to consider only the cases like you have to answer in either yes or no. So you will get the output high voltage as an output means yes, you will get low voltage as an output means no. So one will be representing the high voltage and also the logic yes, and 0 will be representing the low voltage and also the logic no. So uses binary values 0 and 1 to simplify this type of expressions. Boolean algebra simplifies the logic circuit design. It is used in the digital circuits, programming circuits, artificial neural network, artificial intelligence, and networking. Now, Boolean laws and the theorems. The first law is your identity law. Second, null law, complement law, idempotent law. So, for example, say a plus 0a equal to a dot 1 equal to a plus a bar equal to 1, a dot a bar equal to 0. Now, De Morgan theorem. So, in De Morgan's we have two theorems. It is used to convert the logic expression to the simple form. How to convert a logic expression into the simpler form? Suppose we have a plus b bar, then it will be equal to a bar dot b bar. Next, we have ab whole bar, so it will be a bar plus b bar. So used to simplify the logic circuits. A truth table for Boolean expression and or not XOR XNOR. So step by step truth table evaluation. So this is what I had already explained in the previous slide, and or not XOR and XNOR. Now kernel map introduction. So graphical method for Boolean simplification. If you go for the logic simplification in the Boolean algebra, it is very lengthy. So the best approach or the easier approach to simplify these logical expressions in Boolean expression using K-map, and it is used to minimize the logic